settle in and let your breathing slow, because the wind out here has nowhere to hurry to. You think Antarctica is all soft snow and endless white, but you are standing on bare stone, dry dust, and cold that feels carefully stored. The air is so clean it almost seems unfinished, and the silence is so wide you can hear it resting. Tonight, with your tired guide, the Sleepless Geographer, you drift into the dry valleys, where glaciers creep without melting, where lakes hide under ice like sealed letters, and where erosion works patiently, without drama. Nothing here wants your attention. It just keeps going, and you can too. You take a few careful steps, and the first surprise is how un-Antarctica this looks. No friendly blanket of snow, no soft, forgiving drift to hide what the continent is made of. Just rock and dust and a kind of dryness that feels almost insulting considering there is a whole ice sheet nearby, quietly occupying most of the southern hemisphere like it pays rent. The dry valleys sit in Victoria Land, tucked beside the Ross Sea, and they are some of the most barren places on Earth. Polar desert, technically. That sounds like a contradiction designed by a committee, but you can feel it working. Your lips dry out without asking permission. Your nostrils notice every breath. Even your eyes feel like they are doing more work than they should, just to stay comfortable. And almost nothing smells alive, because almost nothing is alive, at least not in the way your brain expects. There are no wet leaves, no soil perfume, no decay. The air carries stone and cold, and a faint mineral dust that has been waiting a long time for someone to walk through it. You think you are standing on stable ground, permanent ground, a reliable floor. Wrong. This valley is a slow workshop. Wind, ice, and temperature are always touching it, always nudging it, always testing it. Not with drama, not with a single cinematic event, more like the way a key slowly wears smooth in a pocket after years of being carried around. The silence breaks in small ways, a scrape of grit across rock, a distant hiss of wind. Sometimes, if you are unlucky, the far-off crack of ice shifting in a glacier you cannot see yet. It is a sound with no echo, because there is nothing soft here to catch it, and nothing crowded enough to throw it back. The cold is not the theatrical kind, not the kind that bites like a wolf. It is the careful kind. It sits on your skin like a thin sheet of metal. It drains heat patiently, as if it has all night, which in Antarctica, it often does. Look up, and the light feels strange. In summer, the sun circles without leaving. In winter, it disappears, like it got bored. Either way, your sense of time starts to loosen. That is one of the first things these valleys take from you. Not your breath, not immediately, just your normal pacing. Your inner clock starts to stutter, then quiet down, and then you notice the color. People imagine Antarctica as white, but here, the palette is all muted browns, old reds, and gray stone. The kind of colors that look like they have been left out for decades. Rust-stained slopes, dark gravel, pale patches where old ice clings to shadow like it is refusing to move out. You are in a place where the continent has taken its mask off. And the reason it can stay like this, the reason this valley can remain so dry while surrounded by ice, is mostly the wind. It is always the wind. It always thinks it is the main character. The first time you feel it properly, it does not arrive like a gust. It arrives like a decision, a steady push, low and purposeful, sliding down from higher ground. In these valleys, cold air can pour downhill, heavier than the air below it, like an invisible river made of weather. This is one of the quiet engines of the dry valleys. Katabatic winds. That word sounds like a tool you would use to remove a stubborn bolt. And honestly, it fits. These winds are dense, cold air masses that sink and accelerate as they descend, guided by the shape of the land, funneled through gaps and over ridges. You stand there and you feel the air moving with intent, not swirling, not playful, just flowing. It scrapes at your jacket. It finds the weak spots near your collar. It tugs at anything loose, because here the wind is not competing with trees or buildings or humidity. It has room to stretch out. And this is how you get dryness in the cold, because cold air cannot hold much water vapor to begin with, and when it moves fast, it steals what little moisture there is. Any snow that tries to settle gets pushed around, scoured away, or sublimated, turning from solid ice directly into vapor, skipping the messy stage of melting like it has better things to do. Congratulations, you have arrived somewhere so cold and so dry that even snow struggles to stay. The valleys are also sheltered by mountains, the Transantarctic Mountains, which act like a wall. Storms coming in from the coast can drop their moisture before reaching the interior. By the time the air makes it here, it is tired and empty. It has already spent its water elsewhere. So what you get is this, a valley floor that looks like Mars tried to copy Earth from memory. Gravel, boulders, dust. The occasional patch of ice that has survived by staying out of the sun. And above it all, wind that never seems to stop showing up for work. You crouch and pick up a pebble, and it is absurdly clean. No film of dampness, no soft layer of organic dirt, just rock, dry enough that it feels warm for a moment, simply because your fingers are warmer than the world around them. And as you walk, you notice the ground is littered with stones that look arranged, not stacked, not placed by hands, but sorted. Finer material here, coarser gravel there, little stripes and patterns, as if someone combed the valley with a giant rake. That is the freeze doing its quiet craft. When the temperature swings above and below freezing, even slightly, ice forms in the spaces between grains. It expands, it pushes, it lifts small stones upward. Then, when it relaxes, the stones settle in a slightly different place. Over years, and then decades, and then the kind of time you stop counting, the ground sorts itself. Stones migrate. Fine dust shifts. Patterns appear, not because anyone planned them, but because physics is persistent and bored. You can call it frost heave. You can call it cryoturbation, which sounds like a polite way of saying the ground is being slowly scrambled. Either way, the result is a valley floor that has been gently rearranged by temperature, over and over until it starts to look intentional. This is what passes for activity here. Slow motion, small motions that add up to landscapes. And the wind helps too. It carries grit like sandpaper. It pushes tiny particles along the surface in short hops. That process has a name: saltation, which sounds like something graceful. It is not. It is the planet flicking grains of sand at rocks for thousands of years. until the rocks get tired and smooth out. Some stones develop ventifacts, faces and edges carved by wind-driven grit. Natural sculptures shaped by irritation. You can run your glove over a sharp ridge and imagine the wind working like an apprentice, filing down a block of stone, one impatient gust at a time. You might expect the wind to howl. Sometimes it does, but more often it is simply present, a continuous pressure that makes the landscape feel exposed, like the valley has no privacy, like everything is being watched and worn down. And that brings you to the next surprise, the ice. Because here, ice does not behave like the ice back home. It does not melt and run off in cheerful streams. It does not drip from eaves. It does not politely retreat when the sun comes out. In the dry valleys, some glaciers are cold-based. That means their bottoms can be frozen to the ground, locked in place. They still move because ice is not truly solid in the way you want it to be. It flows slowly under its own weight, but it does not slide easily on meltwater because there is not much meltwater to help it. So instead of a glacier that grinds the valley floor like a conveyor belt with teeth, you can get a glacier that creeps with restraint. It deforms internally, inching forward through time like a slow breath you barely notice. You see one now, spilling down from a higher place, a pale tongue of ice pushing into a valley of brown rock. It is beautiful in the way a blank page is beautiful. Smooth in some parts, cracked in others, blue-white where it is dense, dusty where the wind has sprinkled it with grit. And you think, for a moment, that this is the only water around. But the dry valleys have a stranger secret. Lakes that hide under ice, not puddles, not ponds, actual lakes. Liquid water sealed beneath lids of ice that can be many feet thick. The surface is solid, wind-polished, and cold enough to burn. But below, in the dark, there can be water that stays liquid because the ice above insulates it, and because salts can lower the freezing point, and because the sun, in summer, can deliver a small amount of energy through the clear ice. It is quiet chemistry, quiet physics, quiet survival. Lake Bonny, Lake Frexel, Lake Hoare. Names that sound like people you might meet in a small town. Not bodies of water trapped under permanent ice. And yet, here they are, held in place like secrets. You walk toward one of these lake basins, and the air changes slightly. Not warmer, just different. The wind skims over the ice surface and carries a sharper cold. The light reflects up, and your eyes squint against a brightness that does not feel friendly. The lake ice can be clear in places, clouded in others, layered like old glass. Sometimes you can see bubbles trapped inside, frozen in mid-rise, tiny spheres of past summers stuck forever in the act of trying to escape. And underneath, a stable world. In a normal lake, wind mixes the water. Seasons turn it over. Warm water rises and falls. Nutrients circulate. But in these sealed Antarctic lakes, the layers can stay separated for long periods. The water can stratify with different salinities, different temperatures, different chemistry stacked like slow layers of thought. Some of these lakes have brines, saltier water that stays liquid even at very low temperatures. Brine that can seep out of the ground in stained streaks, dark lines on white ice or pale soil. There is a famous example called Blood Falls, where iron-rich, salty water emerges and oxidizes, turning the ice a rusty red. It looks dramatic. It looks like the continent is bleeding. It is not. It is just chemistry doing what chemistry does without caring how it looks to you. The life here is not gone. It is just small and patient and mostly invisible unless you know where to look. Microbes in the lake water, algae in thin bands where light can reach, communities that survive on minimal energy, living slowly, repairing themselves slowly, dividing slowly. It is life adapted to the idea that nothing is in a hurry. And for you, standing above it, it is a reminder that water is not just a thing you drink. It is a system, a way of moving heat and minerals and time around the planet. Even here, where everything seems paused, water is still working. But it works in brief appearances. In the warmest part of the Antarctic summer, when the sun circles and refuses to set, some glacier edges can melt just enough to create meltwater streams. Not rivers you can float. Thin, quick trickles that run over gravel for a few weeks. Sometimes only a few days, then vanish again. They run like messages sent in a hurry. A little water released, a short journey downhill, and then either freezing or soaking into the ground or feeding a lake under ice. You can follow one now, a shallow ribbon cutting through brown sediment. It murmurs softly, not because it is large, but because the silence is so complete that even a small movement becomes a voice. This is the rare sound of liquid in a frozen place. And it has a job. Even in the coldest quiet, water still knows how to carve. It does not need a flood. It does not need a roaring canyon river. Give it a slope, a little time, and a few grains of sand, and it will start the slow demolition. It will pick up fine particles and carry them. It will undercut a tiny bank. It will leave behind a small fan of sediment where the flow spreads out and loses energy. Over seasons, those small actions become visible. Dry channels etched into the valley floor. Little deltas where a stream meets a lake ice edge. All the same shapes you see in warmer places, just slowed down, simplified, stripped of vegetation and noise. You step across a dry stream bed and it crunches underfoot like broken pottery. The gravel is sharp. The channel edges are crisp. In most places on Earth, plants would soften this. Roots would bind the soil. Here, there is nothing to hide the geometry of erosion. And then you remember the negative constraint again, the thing you thought you knew. You thought erosion needed water in abundance. You pictured rivers, rain, storms. But here, erosion is stingy. It works with what it can get. A few weeks of meltwater, wind-driven grit, the expansion of ice in rock cracks. Freeze-thaw is one of the main sculptors in these valleys. Even if thaw is a generous word, water finds its way into tiny fractures in rock. It freezes. It expands. The crack widens. The rock weakens. Then, when conditions allow, fragments break loose and tumble down slopes. It is not dramatic. No booming collapse most of the time. Just a click, maybe a quiet shift, a new stone on the talus slope that was not there yesterday. Congratulations, the mountain is falling apart, and it is doing it politely. Talus piles gather at the base of cliffs, like the cliff is shedding. Pebbles and boulders accumulate in cones and fans, each piece a small surrender to gravity. And gravity, of course, is the one force never takes a day off, not even in Antarctica. Sometimes the ground itself creeps downhill. Soil creep, though calling it soil is generous. More like regolith, broken rock fragments and dust. Each freeze lifts particles slightly, each thaw lets them settle a little lower, and over time, the whole surface migrates downhill like a slow spill. No one is watching, no one is applauding. The valley just keeps adjusting its posture. There is a calmness to that if you let it in. Because the dry valleys are not trying to be beautiful, they are not trying to impress you. They are simply what happens when you combine cold, dryness, wind, and time, and then remove most of the life that usually covers Earth like a blanket. And yet, the details are quietly rich. Look closely at a rock surface, and you might see a varnish, a darkened skin formed by minerals and exposure. Look at the soil, and you might see salts, pale crusts, small crystals collecting. Where water once evaporated long ago, the air is so dry that when moisture appears, it does not stay. It either freezes or it leaves. Salt is one of the more subtle destroyers here. It grows in cracks. It expands as crystals form. It pries flakes off rock surfaces the way ice does, but with chemistry instead of temperature. Slow pressure, applied in tiny spaces, repeated until stone gives up. The colors tell you stories too, if you are willing to listen without demanding excitement. Rusty browns from iron, pale grays from weathered rock, occasional greenish stains where minerals concentrate, and always, in the distance, the blue-white edge of glacier ice, like a quiet boundary between worlds. It feels like walking through a museum where nothing is behind glass, because nothing needs protecting from fingerprints. The real threat is the environment itself, the air, the cold, the wind, the sheer slowness of change. And of course, there is the other threat, you. Humans are not meant to be here. Not really. You can visit with layers and equipment and careful planning. But living here casually, the way you live in a damp city or a temperate forest, is not on the menu. The valley does not hate you. It does not even notice you, but your body notices it. You stand still for a while and you feel moisture leaving you, not in sweat necessarily, just evaporation from your breath, from your skin, from the tender places you forget, are exposed until they start to sting. The cold air is dry enough. The dehydration can sneak up quietly. You do not feel drenched, so you assume you are fine. But every exhale is water lost. Every hour is a small subtraction. The wind helps too, because it pulls moisture away faster. It is like living inside a giant air drying machine, except the machine is the planet and you cannot turn it off. And then there is the cold's effect on your mind. Cold does not just chill your fingers, it dulls you. It slows the small decisions. It makes simple tasks feel complicated. Zippers become puzzles. Gloves become obstacles. You start to understand why explorers wrote about the cold as if it had a personality. Not because it is alive, but because it changes you. And that feels personal. Out here, distance is not a number on a map. It is risk. The horizon looks close because the air is clear. You can see far, and that makes you think you can walk far. But the ground is rough, the cold is draining, and help is not nearby. Help is not even a radio call away sometimes. It is a concept, a plan, written on paper, a chain of logistics that only works if nothing goes wrong. And things go wrong very easily when your fingers are numb and the wind is sanding your attention down. That is the calm reality check of the dry valleys. They are not theatrically deadly, they are simply indifferent, and your body is fragile. You can survive here, briefly, with preparation, but you would not thrive. Not in the way you imagine thriving. Not with gardens and open windows and careless walks at night. The valley does not allow casualness. It turns casualness into a problem. And if you make a small mistake, it becomes a permanent plan. Because everything is slow and unforgiving. A twisted ankle is not an inconvenience. It is a new situation you must live inside. A dropped glove is not a minor annoyance. It is a countdown. So you keep moving carefully and you let the thought of survival drift away. Because tonight, you do not need to prove anything. You are only here to witness how the world behaves when it is stripped down to basics. Wind, stone, ice, time. And once you have felt how a place can be this dry, while surrounded by ice, you start to notice the real architect here, the wind. It keeps returning, reshaping the valley in small, relentless gestures. It funnels through gaps, accelerates over ridges, and sweeps loose dust into thin sheets that skim across the ground. In some places, it piles snow into odd corners, and in others, it removes it completely, exposing darker rock that drinks sunlight and changes the local temperature by a tiny, important amount. The wind does not sculpt like a hammer, it sculpts like a file. And as you stand there, listening to that endless sanding, you begin to understand something quietly unsettling. Places like this are not rare accidents. They are what happens when Earth's systems line up in a certain way. Cold, dry air, mountains that block moisture, persistent winds, a landscape left open to the elements for long stretches of time. And when those systems line up, they create a kind of weather that behaves like plumbing, except the pipes are valleys and the water is air. You feel it most at night, or in the long Antarctic almost night, when the high interior cools even further. Cold air gets denser, heavier, and it starts sliding down slope under its own weight. Not because it wants to, because it has to. Gravity works on air too, and in the dry valleys gravity has excellent visibility. These downhill winds are not a single gust. They are a routine. Air spills off the polar plateau and funnels through gaps like it has a destination, picking up speed as it drops. It is the same logic as a river steepening through a canyon, except this river is invisible and it is stealing moisture instead of carrying it. You think wind is chaotic, random, a tantrum. Wrong. A lot of it is stubborn physics, repeating the same behaviors whenever conditions are right. The katabatic flow forms, accelerates, and stays surprisingly organized, like a long, cold freight train you cannot see, but you can hear it in the grit. And because the air is so cold, it holds very little water vapor in the first place. Any humidity that does exist is fragile. It is a thin budget, and the wind spends it immediately. Your breath is proof. You exhale warmth and moisture, and the air takes it like a tax. Sometimes the wind is strong enough to push snow around without mercy. Snowflakes land, try to settle, and get dragged back into motion. If they do manage to stay, they are often erased another way. Sublimation, that is the trick where ice turns straight into vapor, skipping the liquid stage. It is the planet refusing to do dishes. No meltwater mess, no puddles, no dampness. Just gone. That is one reason these valleys stay so bare. It is not only that snow does not fall much, it is that snow cannot reliably stay. It arrives like an uninvited guest, and the wind escorts it out again. Now add the mountains. The Transantarctic Range stands nearby, a long wall of rock and ice. Moist air from the coast gets lifted as it approaches, cools, and drops its snow on the seaward side. By the time any of that air limps over the ridge into the valleys, it is wrung out, empty, like a sponge that has already been squeezed. Congratulations! You are standing in a rain shadow so thorough it feels personal. And dryness does something else out here. It makes temperature swings more brutal. Moist air can buffer changes. Humidity carries heat and shares it around. Dry air does not bother with that. It lets the sun warm surfaces quickly, then lets heat escape just as quickly when the light shifts. So the rocks and soils are always being asked to expand, contract, tighten, loosen. A slow cycle of stress. You can hear the results sometimes if you stand still and let the place speak. A faint tick, a microscopic pop, not loud enough to startle you, just enough to remind you that stone is not calm. Stone is just slow. And while the wind is busy sanding everything down, it is also sorting the world into neat little categories. Fine dust gets lifted and carried farther, staying airborne longer. Heavier sand hops along the surface in short jumps. Gravel barely moves unless the wind is truly committed. Over time, the ground becomes patchy and patterned, as if someone spilled different sizes of cereal and then waited 10,000 years for it to arrange itself. This is why some slopes look dusted and smooth, while nearby patches look like rough gravel armor. That gravel layer can actually protect what is beneath it. A cover of stones shades the finer sediment, reduces wind erosion, and keeps the ground a little more stable. It is called desert pavement in other deserts, and it shows up here too. Proof that Antarctica can do desert tricks without ever getting warm. If you kneel and look closely, you might see the tiny polish on individual stones. Wind polish is subtle. It does not shine like a mirror. It looks more like the dull gleam of something handled too often. The planet's fingerprints, rubbed into rock. And because there are so few plants, there is nothing to interrupt any of this. No roots to hold soil together. No stems to slow wind near the surface. No canopy to trap drifting snow. The atmosphere touches the ground directly, like an open hand on bare skin. That intimacy between air and rock is part of what makes this place feel exposed. It is not just that you are cold, it is that the valley has no curtains. But wind is only half of the dryness story. The other half is the cold itself. Because in cold places, water behaves like a reluctant employee. It shows up late, does very little, and leaves early. Liquid water is rare here, and when it appears, it has to move quickly. It cannot wander. It cannot linger in a puddle and think about its life choices. It runs thin and shallow, hugging dark ground that has absorbed enough sunlight to cross the melting threshold for a brief time. So when the meltwater comes, it has urgency. It carries fine sediment in a hurry, cuts narrow channels, and then vanishes. You can find those channels later, dry and crisp, as if the water carved them with a knife, and then put the knife away. You follow a dry channel now, and you notice something interesting. The bed is often lined with rounded pebbles in some stretches, then suddenly angular fragments in others. That is a clue. Rounded stones mean transport, even if it was brief. Angular ones mean they broke nearby and have not traveled far. The valley is a scrapbook of little movements. And then you notice the fans, small, gentle cones of sediment where a stream once spilled out of a narrow path and lost energy. In warmer places, fans can be massive and obvious. Here, they are modest but precise, like a diagram in a textbook drawn with real gravel. All of these details point to a landscape that is not frozen in time. It is just operating at a pace that makes human life feel frantic. A melt season might last a handful of weeks. A single unusual warm day can matter. A slightly dustier glacier surface can absorb more sunlight and produce more trickles. Tiny changes amplified by patience. And patience is what the ice has in abundance. Out here, glaciers are not the sloppy, wet kind you see in documentaries about melting. Many are cold-based, frozen to the ground. They do not bulldoze the valley floor the same way temperate glaciers do. They can preserve the land beneath them, like a lid placed gently over a table. That is part of why these valleys are scientifically treasured. Some surfaces may have been exposed for millions of years with relatively little disturbance. The rocks have been sitting in the open, under cold and wind, while most of the world got busy with forests and rivers and civilizations. It is an uncomfortable thought that your entire species could rise and spread and record its history, while a pebble here barely shifts. Now you drift closer to the edge of a glacier tongue, where ice meets gravel, like a pale wall meeting a dark floor. At the margin, the ice can be surprisingly dirty. Wind drops dust, tiny rocks fall onto the surface. When sunlight hits that darker material, it warms faster than the clean ice around it, so it melts downward, forming little holes, cryoconite holes, if you want the official term. Cryoconite is basically dust and grit and organic specks gathered into small dark patches. In other parts of the world, those patches can host microbes, tiny ecosystems in miniature melt pools. Here, life can still show up in small ways, clinging to the edges of what is possible. You are looking at biology hanging on by its fingernails. If you are unlucky, you step too close, and your boot crunches into a thin crust. Not into open water usually, more like into a fragile surface layer that gives way into a small pocket. It is a reminder that ice is not always a solid floor. It is a material with moods shaped by light, dust, and temperature gradients. And the glacier itself is moving, even if it looks like a static sculpture. Ice flows. It deforms. Under its own weight, it creeps downhill. Not fast, not even in a way your eyes can catch. But it is happening all the same, like the slow settling of an old building. You can tell movement has happened because of the cracks. Crevasses open where stress exceeds what the ice can handle. In these cold conditions, the crevasses can be sharp and clean, their edges not softened by melt. They look like the ice has been scored. And occasionally, you find something stranger. A line of boulders riding on the glacier surface like a convoy. Rocks fall from valley walls onto the ice, then get carried along as the glacier creeps. When the ice eventually retreats or sublimates, it drops the rocks in ridges and piles, moraines, the glacier's clutter left behind. In wetter places, moraines can be reworked by streams and plants. Here, they can remain stark, almost too clear, like the glacier signed its work and walked away. You continue toward one of the sealed lakes, and the ground changes underfoot. The sediment near the basin is finer. It crunches less, dusts more. And the air above the ice has a particular sharpness, a cold that feels cleaner than cold should feel. The ice lid is thick enough to walk on in many places, but you do not. You keep to the edge because the lake is not interested in your confidence. The surface can be a mosaic of textures, wind-sculpted ridges, smooth clear patches, cloudy layers that look like frozen smoke. Light enters the ice and scatters. It gives the lake a faint inner glow, as if something is lit beneath. And in a way, something is. Sunlight can penetrate meters of clear ice, delivering just enough energy to keep water liquid below. Especially when salts are involved. Salt matters here more than you would expect, because salt is the great rule bender of freezing. Dissolve salts into water and the freezing point drops. That is why roads get salted in winter. That is why seawater can stay liquid below 0 degrees. And in these valleys, salts concentrate in strange places. Where does the salt come from? Some is ancient marine influence. Salts left from times when climate and sea levels were different. Some comes from weathering of rocks. Some comes from the atmosphere. Tiny aerosols carried inland and deposited. And because there is so little liquid water to flush anything away, salts can accumulate in soils and basins over long stretches of time. So in parts of these lakes, you can get dense brines, layered water with different salinities, different temperatures, different chemistry. The lake becomes a stack of invisible worlds, each one reluctant to mix with the others because density differences keep them stable. Stratification, if you want the tidy term. A lake that refuses to stir. That stability is why scientists love these places. They are natural laboratories. Conditions stay consistent enough to study slow processes, microbial survival, chemical gradients. But for you, tonight, the interesting part is simpler. Water is still here, just hidden, conserved, rationed. And sometimes it escapes. There are moments when a briny seep appears at the surface or along a slope, leaving a dark stain. It looks like wet ground, which immediately makes your brain perk up because wetness is rare, and your instincts still believe wetness means safety. It does not. A brine can be cold enough to burn, salty enough to dehydrate skin, and chemically harsh in ways you do not want to test. It is liquid, yes, but it is not friendly. It is water that has been forced into compromise. Blood Falls is the famous example where iron-rich brine emerges and turns red as it oxidizes in the air. It is visually dramatic, which means humans talk about it more than they talk about the quieter brines that do the same thing without theatrics. But the point is not the color. The point is that the dry valleys are not simply frozen. They are complex. They have pockets of movement and chemistry in a place that looks dead from a distance. And all of this quiet activity feeds back into erosion. Because whenever liquid water appears, even briefly, it can mobilize salts. It can soak into soils, then evaporate, leaving crystals behind. Those crystals grow in tiny pores and cracks. Exerting pressure, salt weathering is like ice weathering, except the lever is crystallization rather than expansion from freezing. You find a rock with flaking surfaces, thin sheets peeling away like layers of old paint. That can be thermal stress, freeze-thaw, salt growth, or all of them taking turns. The valley does not need one method. It uses whatever is available. And while all this is happening, the wind keeps polishing, the cold keeps tightening its grip, and the sun keeps circling in summer as if it forgot how to set. There is an odd comfort in how repetitive it is. Not boring exactly, just steady. The world reduces itself to a few persistent forces, and those forces keep doing their jobs. But if you stay long enough, you start noticing another layer of detail, the surface decorations that look like nothing until you realize they are the valley's handwriting. The soil in some places has a pale crust, almost like a dusting of flour. That is salt efflorescence, salts migrating upward through tiny capillaries when moisture is present, then crystallizing at the surface as the water leaves. It is the ground sweating minerals and drying instantly. In other places, the soil is darker and more cohesive, sometimes cemented by salts into a hard pan. It can sound different underfoot, less crunch and more dull tap. If you scrape at it, it resists like a thin crust on stale bread. You see polygons in the ground too, faint outlines forming networks. In the Arctic, in permafrost regions, polygons can form from thermal contraction cracks that fill with ice. Here, the details differ, but the idea is similar. Cold ground contracts, cracks, then those cracks become pathways for ice or salts. Over time, geometry emerges. The landscape starts drawing shapes because it cannot help itself. You walk across one of these patterned areas, and it feels like stepping over a giant tiled floor, except the tiles are made of stone and time. Each polygon edge is a record of stress, contraction, and slow filling. And because nothing grows tall, you can actually see the structure. In most places on Earth, plants cover the evidence. Here, the evidence is the surface. That is why the valleys feel like a museum. Not because they are static, but because the exhibits are not hidden. A moraine ridge sits there like a label. A gravel pavement sits there like a caption. A salt crust sits there like a footnote. Even the colors behave differently. Without vegetation, your eyes stop bouncing between greens. Instead, you read iron stains, basalt darkness. You start to recognize weathering rinds, darker outer layers on rocks that have been exposed longer. You notice how some slopes are striped by sediment layers, ancient deposits laid down in times when ice advanced and retreated differently. Some of those sediments are so old and so undisturbed that they preserve climate history. Dust from faraway volcanic eruptions, tiny particles carried on ancient winds, chemical traces that hint at temperatures long gone. The valley is quiet, but it has a memory. And then you remember, softly, that humans are newcomers. We measure our past in centuries and maybe a few millennia of written record. This place measures its recent history in ice ages. The dry valleys have likely been cold and dry for millions of years, with variations. There were warmer periods in Antarctica's deeper past, when the continent had forests. That sounds impossible, until you remember continents move, climates shift, and Earth does not consult your expectations. Antarctica was not always a frozen fortress. Long ago, it sat in different latitudes, connected to other landmasses. Then, plate tectonics slowly rearranged the map. Ocean gateways opened. Currents changed. The Antarctic circumpolar current formed, isolating the continent with a ring of cold water. And the ice grew more persistent. You cannot feel plate tectonics under your boots, not directly. But you can feel the result, a continent that became its own climate machine, building and maintaining ice on a scale that makes your problems look adorable. And in the dry valleys, you stand in one of the odd exceptions, a small set of basins where ice is nearby, but the air is too stingy to deliver snow. A place where glaciers exist, but do not always erase. Where lakes exist, but hide. Where wind dominates, because nothing interrupts it. You could almost start to think of it as stable, a frozen arrangement, locked in place. But then, you notice how the rocks are breaking apart anyway, how the dust is moving anyway, how the glaciers creep anyway. Stability is just motion that is too slow for your impatience. And speaking of impatience, humans bring it with them like a second shadow. When people do come here, they come carefully. Research camps, helicopter drops, strict protocols. The continent is protected by treaties and rules. And even then, it takes constant effort not to damage what looks indestructible, because this environment is not forgiving. If you leave waste, it does not decompose quickly. If you spill fuel, it does not vanish into a lush ecosystem that can absorb it. If you crush a microbial mat near a melt stream, it might take an absurdly long time to recover, if it recovers at all. Even footprints can last longer than you expect, especially in fragile sediments. You are used to landscapes healing over. Grass grows back. Rain smooths things out. Here, healing is slow, and sometimes it does not happen in any human time frame. So people who work here have to treat the ground like an archive. Step lightly, move deliberately. Assume the environment is recording your mistakes, but your body is still recording the environment too. You have been out here long enough now to feel how dehydration creeps. Your mouth feels drier even when you are not talking. Your skin tightens. The corners of your lips crack if you forget to protect them. And you are not sweating much, which is the trick. In a hot desert, you feel moisture leaving. Here, you can lose water without drama. Cold also changes your appetite and your judgment. You might not feel thirsty, which is a problem because thirst is supposed to be your alarm system. Out here, the alarm is quiet. You have to drink on schedule like a machine maintaining itself. And then there is the simple fact of cold injury. Frost nip, frostbite, hypothermia, words that sound like warnings because they are. Exposed skin can lose sensation quickly in wind, and numbness is treacherous. Pain is annoying, but it is information. When you go numb, you stop receiving updates. Congrats. Congratulations, your body's warning lights are optional out here. Now imagine trying to live a normal day in this. Cooking, repairing gear, walking to a neighbor's house, dealing with boredom. It is not the heroic moments that get you. It is the endless small tasks done with numb fingers and dry eyes and a brain that is slightly slowed. And distance, again, is not a casual thing. The valleys are remote even by Antarctic standards. Supplies come by long logistical chains. Weather can cancel flights. Wind can ground helicopters. A problem that would be minor in a town becomes a serious event when transport is uncertain. If you twist your ankle, you do not limp to a clinic. You initiate a plan, you become a situation. And because cold slows everything, every solution takes longer than you want. Even communication can be weirdly fragile. Radios depend on power. Power depends on fuel or solar. Solar depends on light. And light depends on season. Antarctica is not trying to kill you. It just does not care if your systems fail. That is the calm reality. Your survival here is not about bravery. It is about redundancy, layers, schedules, backup plans, and an acceptance that nature will not meet you halfway. And yet, humans keep coming because the valleys answer questions that matter. They help us understand how life might persist on Mars, where it is cold and dry and salty. They help us understand microbial ecosystems under ice. They help us read climate history and preserved sediments. They remind us that Earth contains environments that feel alien without leaving the planet. But you do not need to be a scientist to feel the message. You just need to stand still and notice how the place runs without you. Wind scours, ice creeps, salts crystallize, rocks flake. The lake holds its breath under ice, and you, briefly, are warm enough to observe it. That thought can make you feel small, or if you are tired in the right way, it can feel relieving. The planet is handling itself. Your job is just to witness. And once you let that sink in, you start noticing a pattern that reaches far beyond Antarctica. Because this kind of dryness is not exclusive to cold. The same broad logic shows up elsewhere, in places where mountains block moisture, where air descends and warms, where clouds get discouraged and give up. So, you let the dry valleys fade slightly into the background, like a low wind hiss behind a radio voice, and you carry the concept with you. Dryness created not by heat alone, but by air movement, by barriers, by shadows. Now the cold loosens its grip, not because you got warmer, but because your imagination walks to another latitude. You step gently into a different empty. The ground is still hard, still sparse. The air is still thin, in a way you can feel in your nose. But now, the light is harsher, and the dryness comes with a sun that does not circle politely. It climbs, stares directly, and bakes the idea of comfort out of the landscape. You are standing in a high desert, the kind that sits behind a mountain range like a secret, a rain-shadowed desert. You might be near an ocean, which seems unfair. You might even smell salt on the wind some days. But the mountains between you and that water are doing what mountains do best. They force air to rise. When moist air rises, it cools. Cooler air holds less water vapor. so the moisture condenses into clouds, then drops as rain or snow on the windward side. Forests drink it, rivers collect it, glaciers store it, and then the air crests the ridge and begins to descend on your side. Descending air warms. Warming air can hold more moisture. So instead of releasing water, it becomes thirsty. It absorbs moisture from the land. It pulls water from soils, from plants, from your mouth. The sky stays clean and empty because clouds struggle to form in sinking air. This is how you get deserts beside oceans. Not because the ocean forgot to evaporate, because the atmosphere and the mountains collaborate to keep the water elsewhere. The Atacama in Chile is one of the famous examples. Sitting between the Pacific and the Andes, cold ocean currents offshore reduce evaporation, while the mountains block moisture from the east. The result is a place so dry that parts of it go years without meaningful rain. It becomes a desert that feels like a paused scene. Or you can think of the Great Basin in the western United States, where multiple mountain ranges create layers of rain shadows. Moisture gets wrung out again and again, leaving basins that are dry, salty, and stark. Or the Tibetan Plateau's edges, where altitude and rain shadows create cold, arid zones that feel like another planet. High deserts can be hot in the sun and brutally cold at night because thin, dry air does not hold heat well. It lets warmth escape into space like a secret. You feel that contrast in your own body. In the sun, your skin warms quickly. Step into shade, and the warmth drains away. The desert has no loyalty. It gives and takes without apology. Your lips crack faster than you expect. The inside of your nose feels too dry. The air makes you thirsty before you even start walking. And above you, the sky is almost aggressively clear, a hard blue that looks painted on. In a humid place, the world feels soft around the edges. In a dry place, everything looks sharper. Distances look shorter. Mountains look closer than they are. Your eyes can see far, and your legs will pay for believing them. And then, night arrives. Heat leaves quickly, radiating away from the ground into an open sky. The temperature drops with an efficiency that feels rude. In a few hours, the desert goes from sunburn to frost. Your breath becomes visible. The same air that roasted you now steals your warmth because it was never on your side. Life here survives by doing less. Plants grow low, waxy, with small leaves to reduce water loss. Some open their pores only at night to take in carbon dioxide when it is cooler, then close them during the day. It is a strategy called crassulaceae in acid metabolism, which sounds like a medical condition. It is really a plant's way of being sneaky with gas exchange. Animals are often nocturnal, avoiding daytime heat. Some burrow, using the ground as insulation. Some have kidneys that concentrate urine to conserve water. Some eat seeds and insects that contain the moisture they need, living without ever drinking from open water. And humans, as always, build systems, wells, canals, reservoirs, arguments over water rights. Because water is not just a resource in dry lands, it is the limit. You can have fertile soil and plenty of sunlight, but without water, none of it matters. So, civilizations in deserts often cluster around rivers that originate in wet mountains. The Nile, fed by rains far away. The Indus, fed by Himalayan snow and glaciers. The Colorado, carved from Rocky Mountain precipitation. and now asked to supply more people than it comfortably can. Deserts teach you a simple truth. Most places do not have water because they deserve it. They have water because geography allows it. A mountain range in the wrong place can turn a green coast into a brown interior. A shift in wind patterns can move rain belts and change entire regions. And that should feel familiar now, because you have already seen it in Antarctica. The dry valleys are a polar version of a rain shadow story. Mountains blocking moisture, descending dry air, wind doing most of the work. Different temperature, same indifferent logic. But deserts have another habit. They preserve things. Because there is less water to rot wood, less plant growth to churn soil, less biological activity to erase traces, footprints can last. Ancient roads can remain visible. Mummies can stay intact. Old lake beds can sit as pale flats, cracked like pottery, holding salts that glitter when the sun hits them. Sometimes, a desert reveals that it used to be wet, shorelines etched into hillsides, river channels that now carry only dust, fossils of fish and rocks that are currently miles from any water. It is a reminder that climate is not a permanent personality. It changes, sometimes dramatically, as Earth's systems shift. You walk across a salt flat now, and it crunches underfoot. The surface is a crust, white and geometric. Under that crust can be mud, brine, or more salt. Salt flats often form in endorheic basins, closed drainage areas where water flows in but does not flow out to the sea. Instead, it evaporates, leaving minerals behind. Over time, those minerals accumulate: sodium chloride, gypsum, borates, lithium salts. The basin becomes a chemical savings account, built deposit by deposit. And humans notice. They always notice. Lithium, for example, gets scraped from some salt flats for batteries. Borax was hauled out of deserts by mule teams because industry wanted it. Salt itself has been mined and traded and fought over for centuries because your body needs it and your food preservation used to depend on it. Congratulations. Even emptiness has a supply chain. But standing here, you are not thinking about industry. You are thinking about how the ground can look so smooth and so cracked at the same time. The polygons form as the surface dries, shrinks, and fractures. It is a desert's version of patterned ground. Geometry again, emerging from stress. And if you keep walking, you eventually reach the edge where dryness meets something else. Maybe mountains rise again, catching clouds. Maybe a river appears, a thin line of green following water like a rumor. Or maybe you reach the coast, because the coastline is where the planet does its most patient erasing. You stand at the edge of the sea now, and it looks calm, a gentle surface, a rhythmic swell. It is easy to underestimate it. Waves look like they are just arriving to be pretty. But each wave is a moving mass of water carrying energy from storms that might be far away. Wind over the ocean transfers momentum to the surface. That energy travels as waves, sometimes across entire basins, until it meets land. And when it meets land, it has one job. It spends its energy. One wave does not do much. It slaps rock, foams, retreats. It seems harmless, but it repeats again and again, day and night, tides in and out, storms intensifying the process. The sea is a steady argument that never gets tired. You can watch it work on a cliff face, The base of the cliff is wet and dark, battered by spray. The rock has fractures, weaknesses, bedding planes. Waves push water into those cracks, compressing air inside, forcing pressure changes. Over time, the crack widens. Salt from seawater crystallizes as spray evaporates, prying at pores. Chemical weathering alters minerals. Algae and small organisms attach, their tiny lives contributing to surface breakdown. Then, one day, gravity finishes the sentence. A section of cliff collapses. Not necessarily during a storm. Sometimes it happens on a quiet afternoon. The cliff simply reaches a point where its overhang can no longer pretend. It falls, and the beach below gets a sudden delivery of fresh rock. If you are not there, you will never know the moment. You will just see the new scar later, raw and bright against older weathered surfaces. That is how coasts behave. Slow change, punctuated by sudden release. And what happens to the fallen rock? The sea does not leave it as a neat pile. Waves pick up fragments and grind them. Rocks collide, edges chip, corners round. Over time, boulders become cobbles. Cobbles become pebbles. Pebbles become sand. Sand becomes silt. Silt becomes suspended sediment, drifting away like smoke in water. A beach is not a static place. It is a temporary storage zone. Sand arrives, rests, and leaves again. Longshore drift moves sediment along the coast, driven by waves arriving at an angle. The beach is constantly being rearranged, like a rug being tugged sideways one thread at a time. You can see this in the way spits form, long, narrow extensions of sand reaching out into bays, or barrier islands, ribbons of sand protecting lagoons, migrating landward over time as storms overwash them. Or tombolos, sandy bridges connecting islands to the mainland, built by currents that decide where to drop their load. Humans draw a line on a map and call it a coast. The ocean laughs quietly and moves the line anyway. And then there are tides, the daily breathing of the sea under the pull of the moon and sun. Tides expose rock platforms, then cover them again. They bring salt water into estuaries, mix fresh and marine waters, create shifting zones where organisms adapt to constant change. In some places, the coast retreats rapidly, losing meters in a stormy season. In others, it advances, building new land through deposition. River deltas can grow outward when sediment supply is high, then shrink when dams trap sediment upstream. The coast responds to both ocean energy and what the land delivers. It is a negotiation, and it never ends. You walk along a shoreline where cliffs meet the sea, and you notice the debris at the base. Fresh, angular blocks near the collapse zone. Older, rounded stones farther along, already worked by waves. Driftwood bleached pale, thrown above the high tide line during storms. Seaweed drying in tangles, crackling underfoot. The air smells alive here, in a way the dry valleys never did. Salt, algae, decay, and whetstone. It is a different kind of harshness. Not sterile, busy. The sea is full of organisms and chemistry, and it spreads that complexity onto land. But it is still indifferent. It just has more textures And if you climb a little above the beach, you can sometimes see terraces, flat steps carved into coastal hillsides. These can form when sea level stays steady for long enough to cut a platform. Then, sea level changes and the platform is lifted or left behind. Sea level changes because ice ages store water as ice, lowering oceans, then release it, raising them. Land can also rise or sink due to tectonics or isostatic adjustment. Isostatic rebound. It sounds like a yoga move, but it is the crust's slow recovery after being pressed down by ice sheets. When a heavy ice load melts, the land beneath begins to rise again, very slowly, like a mattress regaining shape after someone finally stands up. In places like Scandinavia and parts of Canada, the land is still rebounding from the last ice age. So a coastline is not only shaped by waves, it is shaped by the entire planet's weight shifting over time. Which brings you to the biggest motion of all, the one so slow you cannot feel it without mountains as evidence. Because mountains are not just scenery, they are consequences. You stand far inland now, away from the sea's breath, and you face a wall of rock rising into the sky. The air gets thinner as you climb. The temperature drops. The wind changes character. And you think, instinctively, that mountains are permanent. Wrong again. A mountain range is a bruise on the crust. It forms when tectonic plates push together, compressing rock, folding it, faulting it, thickening the crust until it rises. It is like two shopping carts colliding in a parking lot. Except the collision takes tens of millions of years, and instead of dented metal you get the Himalayas. There are different ways to build mountains. Continental collision is the dramatic one, when two buoyant continental plates meet and neither wants to sink. So the crust crumples and thickens. The Himalayas rose as India pushed into Asia, and the process is still happening. The mountains are still rising in places, even as erosion tries to shave them down. Subduction zones build volcanic mountain chains, where an oceanic plate sinks under another plate and melts, feeding magma that rises and erupts. The Andes, the Cascades, island arcs like Japan. These mountains are not just uplifted crust. They are built from repeated eruptions, layers of lava and ash, stacked like dangerous cake. Then there are rift mountains, formed when the crust stretches and breaks, creating fault blocks that rise and fall. East Africa's rift valleys, for example, mountains can form from pulling apart as well as pushing together, because the crust is always trying new ways to fail. But regardless of how they form, mountains share a fate. The moment they rise, they start being dismantled. Wind, water, ice, gravity, all attack high ground. Rivers cut valleys, glaciers carve cirques, and U-shaped troughs. Freeze-thaw shatters rock. Landslides drop whole slopes at once. The mountain is always losing material downhill, grain by grain, boulder by boulder. So a mountain range is a balance between uplift and erosion. Build up versus tear down. If uplift wins, peaks rise. If erosion wins, the range lowers and smooths. Often, they reach a rough equilibrium, a steady height maintained by constant loss and constant replenishment from below. It is not a static monument. It is a conveyor belt of rock. You can see the conveyor belt in the rivers. High in the mountains, snow accumulates. In warmer seasons, it melts, feeding streams. Those streams join, grow into rivers, and carry the mountain away as sediment. Every grain of sand in a downstream delta was once part of some older mountain. Every muddy flood is a delivery of eroded rock. Rivers are not peaceful. They are logistics networks for destruction. They cut into bedrock with abrasion, dragging sediment like sandpaper. They exploit fractures and weak layers. They undercut banks and trigger collapses. They meander across floodplains, chewing one side, depositing on the other, migrating like restless animals. In steep terrain, rivers can incise quickly, leaving terraces that mark former floodplain levels. In tectonically active regions, uplift can steepen rivers, making them cut down harder. The landscape becomes a conversation between rock rising and water cutting. And above a certain elevation, you get glaciers again, because gravity and cold cooperate. Glaciers form where snow persists year-round, compacting into ice. They flow down slope, carving and plucking rock. They leave behind moraines, drumlins, erratics. They reshape entire mountain valleys, turning sharp V-shaped river valleys into broad U-shapes with steep walls. You stand in one of those U-shaped valleys now, and you can tell ice used to fill it because the walls are too steep and smooth for a normal river. Hanging valleys join from the sides, ending in waterfalls because their glaciers were smaller and did not cut as deep. It is a landscape designed by thickness, and when glaciers retreat, they leave behind unstable piles of debris, outwash plains, kettle lakes, braided rivers weaving through sediment like loose threads, fresh landscapes, raw and easily changed. Humans like to build in these valleys because they are flat, scenic, and often have water. Congratulations, you have chosen to live on a pile of unconsolidated sediment left by melting ice. It will behave beautifully right up until it does not. Mountains also mess with weather. They force air up, creating clouds and rain on one side, dryness on the other. They create microclimates, wind patterns, snow belts. They are not passive lumps of rock. They are climate machines, and they create hazards, avalanches, rockfalls, debris flows, earthquakes. High places are dramatic even when they look calm. A slope can be stable for years, then fail when heavy rain lubricates a layer, or when an earthquake shakes loose what was barely holding. You can walk a mountain trail in silence, listening to birds and wind, while the entire range is slowly grinding down into sand. Deep time makes that feel less frightening and more inevitable. The mountain does not collapse out of malice. It collapses because gravity is honest, and rock has limits. And that honesty is part of what ties all these places together. The dry valleys, high deserts, coasts, mountains, they are different faces of the same planet, shaped by the same few forces. Air moves, carrying moisture or stealing it. Water flows when it can, carving and transporting. Ice creeps and preserves, then releases. Rock breaks chemically and physically, always trending towards smaller pieces, and gravity collects everything downhill, eventually toward the sea. You are a brief observer in the middle of those flows, For now, you let the mountain air thin your thoughts. You let the idea of collision and uplift settle in your mind like sediment in calm water. And you begin to notice how even the highest peaks are temporary, just like coastlines, just like deserts, just like those bare Antarctic valleys. The planet is not building anything to last. It is building things to change. So you take your attention down from the peaks and you notice what the mountains do with all that broken rock they produce. They do not keep it. They shed it into creeks, into rivers, into mud flows, into landslides that look sudden only because you were not watching yesterday. And the rivers carry the whole argument downhill, grain by grain, until the mountain becomes somebody else's beach. You can stand beside a mountain river and hear that work happening, not as a metaphor, as actual scraping. Water pushes stones along the bed. Stones collide and chip. Sand scours the channel like an endless scrub brush. The river is not trying to be loud. It is trying to get its load delivered. And when the river slows, it drops what it cannot carry. Gravel bars appear. Point bars build on inside bends. Fine silt settles where the current loses its patience. Deposition is not a peaceful ending. It is just the river setting something down for later. Later, the next flood will pick it up again. Congratulations! You have found a system that never finishes a task. If you stay with the river long enough, you see the floodplain too. Flat ground, soft ground, ground that looks like a good idea for a farm or a road or a tidy row of houses. And it is, until the river remembers it owns this space. A floodplain is not the river's neighbor. It is the river's spare room. In calm seasons, the channel stays inside its banks and behaves. In wet seasons, when snowmelt surges or storms arrive, the water rises and spreads out. It drops silt, builds natural levees along the channel edges, and leaves behind oxbow lakes where old meanders get cut off. The land becomes a patchwork of former river plans. Humans love these places because they are fertile. Fine sediment brings nutrients. Water is close. The terrain is easy. So you move in, you build, you forget. And then the river politely introduces itself again. That is the mountain's debris in transit, already being repackaged into the next landscape. Now, you follow that chain further. You let the river keep going until it meets the sea. Because that is where the planet's sorting habits become obvious. And it is where the quiet violence changes texture. The river arrives with fresh sediment and a sense of urgency. The sea meets it with salt, tides, and waves that are not impressed. The water slows at the mouth, and the river drops what it has been hauling. Sand and silt fan outward. A delta begins to build. A delta looks calm from above, a branching pattern, a green and brown hand reaching into blue water, but it is unstable by design. Channels shift, sediment piles up, floods jump banks, storm surges push salt water inland. The whole thing is a negotiation between river energy and wave energy, between what arrives and what gets reworked. The Nile built a broad delta because the Mediterranean is relatively gentle with waves. The Mississippi builds fingers of land into the Gulf because it carries so much sediment. But it also abandons those fingers when channels switch. The Ganges and Brahmaputra spread across a wide lowland, constantly rearranging themselves with monsoon floods. If you choose to live on a delta, you are living on a moving conveyor belt. And now, in your mind, that conveyor belt becomes a circle. Mountains rise, mountains erode, rivers transport, coasts grind and redistribute. Sediment becomes rock again over deep time, compressed and cemented in basins. Then tectonics lifts it, and the cycle restarts. That is the planet's habit. Not building permanence, building loops. And loops bring you back to cold again. Eventually, because ice ages are one of the biggest loop makers Earth has. They take water out of the ocean, lock it on land, lower sea levels, and then release it again. Coasts migrate, rivers cut deeper, valleys get carved. Then the ice melts and refills the sea, and shorelines climb back up the continents. You do not need to memorize glacial periods to feel the pattern. You only need to understand that sea level is not a fixed number. It is a mood set by temperature and ice volume. And speaking of ice volume, your thoughts drift south again. Because Antarctica is not just another cold place. It is the planet's deep freezer, the one with the heavy door and the stubborn seal. The dry valleys sit near that freezer, but they are still part of its influence. And once you have wandered through deserts and coasts and mountains, you can return to them with different eyes. You come back quietly to that bare Antarctic rock, and this time, the stillness does not feel empty. It feels busy in slow motion. You remember the katabatic winds, the cold air sliding downhill like an invisible river. You remember the way they steal moisture, turning snow into vapor without bothering to melt it. You remember how the valley floor sorts itself into stripes and polygons, like physics doodling while it waits. Now you notice something even more unsettling. The dry valleys are not just dry, they are preserved. In many environments, evidence gets erased quickly. Plants grow over it. Soils churn with worms and roots. Rain dissolves and transports. Rivers shift their channels and bury their tracks. But here, in the cold and dryness, the erasers are weak. So surfaces can sit exposed for very long stretches of time. Some soils in the dry valleys contain salts that likely took immense time to build up. Some landforms appear almost untouched because the processes that would normally soften them are missing or slowed. And that makes the valleys feel like a landscape holding its breath. It is why people compare them to Mars, and not just because they look reddish and barren. Mars is also cold and dry, with little liquid water to smooth things out. So if you want to know what slow weathering looks like, what long exposure looks like, you come to a place like this and practice noticing. You practice the art of seeing small change. You look at a boulder and see wind polish. You look at a slope and see a talus cone built from countless tiny falls. You look at a soil crust and see salts migrating upward, crystal by crystal. You look at a melt channel and imagine the brief weeks when it runs, carrying silt like a tiny delivery service. And then you look at your own footprints and you understand something oddly personal. You are not meant to last here either. Your tracks might linger longer than they would in a forest, but they will still be edited by wind, softened by time, and eventually blurred into the general texture. The valley has no interest in your presence as a permanent feature. It will file you down the same way it files everything else, not through malice, through routine, That is one reason the place can feel comforting in a grim way. It does not judge you. It does not reward you. It does not remember you the way people do. It just continues. And there is something calming about a world that refuses to be impressed. If you linger near one of the lakes again, you notice how different kinds of time stack on top of each other. The lake ice can hold layered histories, freezing patterns from different seasons. The water beneath can remain stratified, stable, separated into chemical layers that do not mix easily. Microbial communities can persist in those layers, living slowly, adapting to gradients of light and salt. Life, when it shows up here, is not loud. It is not competing for attention. It is simply taking what little energy is available and turning it into continuation. That is the most honest definition of survival. And survival, as you already learned, is not a poetic concept out here. It is logistics and heat balance and water budgets. It is how much moisture you lose with each breath. It is how quickly your fingers cool in wind. It is whether your equipment keeps working when plastic becomes brittle and batteries drain faster. It is a place where mistakes do not get forgiven quickly. They just sit there with you. So you do not romanticize it. You do not pretend you would thrive as some heroic polar wanderer. You accept the boring truth. You are a warm animal built for wetter, gentler places. Congratulations, you have evolved for forests and savannas, and you are currently trespassing in a freezer desert. And yet, the human mind insists on building a narrative anyway. It wants to make the dry valleys into a symbol, the end of the world, the most alien place, the ultimate test. But the valleys do not care about your symbolism. They are not trying to be extreme. They are simply the outcome of geography aligning in a particular way. Mountains, wind, cold, and time, all agreeing to remove softness. When you accept that, you can start seeing the valleys as part of Earth's normal range, not as an exception, a reminder that the planet includes places with almost no biological padding, places where geology shows through. And once you see that, you start noticing how much of your daily life depends on padding, soil that stays moist enough for plants, air that holds water vapor, temperatures that hover in a narrow band where liquid water can exist most of the year, a stable water cycle that keeps rivers running and aquifers replenished. These are not guaranteed features of a planet. They are conditions, temporary, adjustable conditions. The dry valleys are what it looks like when those conditions are withdrawn. Now, you let your imagination walk across the valley floor again, and you pay attention to the little betrayals of solid ground. You step over patterned polygons, and you remember that the crust here is under stress. Not tectonic stress in the moment, thermal stress, contraction and expansion, cracking and filling. And far beneath that, deeper than you can sense, the crust itself is floating on a mantle that moves with slow heat. The continents are not bolted down. They ride. It is easy to forget that when you live in a city and the ground feels like a promise. But here, where nothing pretends to be comfortable, you can accept the uncomfortable truth. The planet is not a finished object. It is a process. Even Antarctica, which looks like an immovable cap, has moved across latitudes over geologic time. It was once part of Gondwana, linked to South America, Africa, India, Australia. That is not a fun fact. That is the reason the ocean circulations changed, the reason the continent became isolated, the reason ice could expand the way it did. When the Drake Passage opened between South America and Antarctica, ocean currents had a clear path around the continent. That helped form the Antarctic Circumpolar Current, a cold ring that keeps warmer waters out. Isolation is not just a social condition, it is a climate engine. And once a big ice sheet forms, it becomes self-reinforcing. Ice reflects sunlight. High albedo, if you want the term. Less absorbed heat means colder conditions, which means more persistent ice. Add the elevation of the ice sheet itself, rising into colder air, and you get a feedback loop that maintains the freezer. So the dry valleys are not just dry because the wind is rude. They are dry because the entire continent is built to stay cold. But even that is not forever. Ice sheets grow and shrink. Climate swings. Even the deep freezer has settings. You do not need to panic about that tonight. You only need to understand that Earth has never promised stability. It offers temporary patterns, and then it rearranges them. Now you walk toward a ridge overlooking the valleys, and the view opens up. Bare rock basins, pale glacier tongues, distant mountains, and beyond them, the larger white mass of the ice sheet that actually does cover most of Antarctica. From here, you can see how the dry valleys are like a small exposed bone near a larger body, a place where the continent's inner structure shows through. And you can also see how wind channels through the terrain. It is not random. Valleys funnel it, ridges deflect it, broad basins allow it to spread. The landscape shapes the atmosphere, and the atmosphere shapes the landscape. A slow feedback loop. The planet is always doing that, coupling systems together. Wind and rock, water and gravity, ice and sea level, tectonics and climate. And humans, small as we are, couple ourselves to those systems too, whether we admit it or not. You can build a base in Antarctica, but you are still dependent on the weather windows. You can build a city in a desert, but you are still dependent on distant snowpack. You can build a seawall on a coast, but you are still dependent on the ocean not arriving higher next decade. The planet lets you borrow space for a while. It does not sell it to you. So you stand there, looking out, and you feel that wide silence again. Not the silence of nothing happening, the silence of things happening on timescales that do not bother to announce themselves. The kind of silence that makes your own thoughts sound a little loud and a little optional. You step down from the ridge, back onto the valley floor, and you let your attention settle into the smaller details again. A pebble with a wind-carved edge, a thin salt crust like frosted glass, a shallow channel etched by brief meltwater, a boulder sitting alone, dropped by ice that has since retreated, leaving it stranded like a forgotten package. Erratics are what those boulders are called when they sit somewhere that does not match the local bedrock. They are clues that ice traveled, carrying cargo. In many places on Earth, erratics are dotted across landscapes as reminders of ice ages. Here, they feel more immediate because so little else distracts you. You can imagine the glacier once thicker, pushing further, dropping rock as it moved, then thinning, retreating, leaving behind a neat ridge of debris. A moraine that looks like it was made by a machine when really it was made by the slowest bulldozer on Earth. And because melting is limited, sublimation matters even more. Sublimation is a strange concept when you first meet it because it feels like cheating. Solid to gas, skipping liquid, but in cold, dry air, it is common. Ice can simply vanish into the atmosphere molecule by molecule, especially when wind keeps removing the thin layer of moisture at the surface. So a glacier in the dry valleys can lose mass without producing much meltwater. It can shrink by evaporation, in a sense. That is one reason you can have ice nearby and still have dry ground. It also means the glacier surface can develop a protective layer of debris. A thin cover of dust and rock can insulate the ice beneath, slowing sublimation in places. So you get uneven surfaces, hummocks and hollows, where debris thickness varies. A place that looks static becomes textured with subtle motion. And then, sometimes, the glacier does something even stranger. It carries ice itself as a kind of buried memory. Some valleys contain remnant ice from older climates, covered by sediment, insulated and preserved. Buried ice can persist for a very long time when temperatures stay low and the cover is thick enough. It is like finding an old freezer stash under the floorboards. If that buried ice ever gets exposed through erosion or a shift in conditions, it can sublimate or melt and destabilize the ground above. You can get collapses, pits, small sinkholes where the support disappears. Again, not dramatic like a movie, just the ground quietly losing its internal scaffolding. The valley teaches you to respect what you cannot see. And it also teaches you how little you actually need to change a landscape if you have enough time. Not a lot of water, not a lot of heat, just repetition. That is the real horror of geology, the cozy kind. It does not need violence every day, it only needs persistence. Now, without warning, you realize you have been thinking in circles, like the planet does. Returning to wind, returning to ice, returning to sediment, returning to time. That is fitting. The dry valleys do not encourage linear storytelling. They encourage loops. So you let your mind loop again outward to other places that share this stripped-down feeling. Not necessarily cold, not necessarily dry, just places where the earth shows its indifference clearly. But before you go too far, you stay here a little longer, because this is still the anchor point. The place you started. The place that keeps refusing to match the postcard. You walk toward a patch of darker ground, and you realize it is not soil in the way you mean it. It is mostly mineral, broken rock, dust, very little organic matter. In most ecosystems, soil is alive with microbes, fungi, insects, roots. Here, soil is closer to powdered geology. Still, even in that powdered geology, there can be life. Endolithic communities, microbes living inside rock pores, using the stone as shelter from wind and radiation. Hypolithic communities, living beneath translucent stones, like quartz, where light can filter through while the stone blocks harsh conditions. Life hiding under a rock, not as an insult, as a strategy. You have to respect the humility of that, the refusal to demand comfort, just a quiet acceptance of whatever micro niche exists. And that is part of why people study this place. Not for beauty, for limits. Where is the edge of habitability? How little water can life tolerate? How does biology operate when energy is scarce and conditions are stable but harsh? What does survival look like when it is measured in slow metabolism rather than rapid growth. You can feel your own metabolism objecting already. You want warmth. You want humidity. You want the casual luxury of not thinking about your fingers. Out here, you become aware of your body in a way that is hard to ignore. Not in a dramatic panic, more like a constant low-level accounting. How much water have you drunk? How dry is your throat? How well are your layers working? How much time do you have before cold starts stealing coordination? That kind of awareness can be exhausting, which is why the valleys can be oddly quieting to the mind. They demand focus, but they do not demand creativity. They reduce your world to a checklist. And if you remove the survival pressure, if you imagine yourself here safely, warmly, only observing, you get something else. A sense of scale. The valley floor has been worked for millions of years by processes that barely register day to day. The rocks have been exposed longer than most landscapes. The ice has come and gone in different extents. The lake levels have shifted. Salts have accumulated, migrated, crystallized, and broken stone apart with invisible pressure. All of that happened without any audience. So when you stand here in your imagination, you are not visiting a stage. You are intruding on a workshop that never closes. And the tools are simple. Wind, cold, gravity, sunlight, chemistry. You can almost hear them if you listen the way you listen to rain on a roof. Not for information, for rhythm. Wind across gravel makes a dry hiss. A small knelt trickle makes a faint murmur. A distant glacier crack makes a sharp punctuation. Most of the time, nothing happens loudly enough to break the mood. The valley soundtrack is absence with occasional edits. Now you drift toward the edge of one of those meltwater channels again, and you let yourself notice how water behaves in a place like this. When melt starts, it often begins at dark surfaces, dusty ice, rocky margins, places where sunlight can be absorbed rather than reflected. The meltwater runs over permafrost, ground that stays frozen below a thin, active layer, so the water cannot soak deep. It stays near the surface, flowing quickly along shallow paths. Those shallow paths can shift year to year. A small blockage of gravel can redirect flow. A patch of ice can force a detour. The channels can braid, split, rejoin. They are like temporary handwriting on the valley floor. And when the water reaches a lake, it can do something interesting. It can flow under the ice lid, through cracks, or along the shoreline, adding fresh water to the top layer. That fresh water can sit above saltier, denser water, reinforcing stratification. So even a brief stream can change the lake's layering. The lake becomes a long-term archive of short-term events. In some of these lakes, you also get moats in summer, narrow rings of open water along the edges where the ice pulls back from the shoreline. That open water can absorb more sunlight and melt more, expanding the moat. But the moat is still cold, still hemmed in, and it refreezes when the season ends. A brief window of liquid exposure, then sealed again. You can see how this would feel alien if you grew up around normal lakes. You expect a surface that breathes with wind, that mixes, that freezes and thaws in a predictable way. Here, the lake is like a vault with occasional small deliveries. And now, because your brain likes to connect things, you remember those other coasts and rivers and deltas. you realize that water does not have a single personality. It behaves according to temperature and gravity and chemistry. In one place, it roars and floods. In another, it hides under ice for years. In another, it vanishes into air without becoming liquid at all. Water is consistent in its goals, though. It moves from high energy to low energy. It dissolves what it can. It transports what it can. It finds the easiest path allowed by physics. In a sense, water is the planet's way of smoothing itself out. And that should make you glance at the mountains again. Because mountains are the opposite of smoothing. They are roughness created by tectonics. The planet wrinkles itself, then water and wind and ice spend millions of years ironing. The dry valleys are one of the ironing boards. Now you walk across a patch of gravel pavement again, and you notice how it crunches differently from finer sediment. Desert pavement forms when wind removes fine particles and leaves behind a lag of larger stones. Over time, those stones can settle into a tight mosaic. It becomes armor against erosion. Made by erosion. That is another loop. You can imagine the valley floor once having more dust. Wind removes it slowly, leaving stones. Freeze and thaw, lift stones and help them settle. Over time, a pavement forms, and once it forms, it protects the fines beneath, slowing further erosion, so the landscape can stabilize itself in patches, even while everything continues moving elsewhere. Stability is always local. Now, because this is still Earth, not a sterile lab, you also have to remember the role of sunlight and radiation. Antarctica has strong ultraviolet exposure, partly because of the ozone hole history, and partly because of the reflective surfaces and clean air. In the dry valleys, with bare ground and bright ice nearby, radiation can be intense. That is another reason microbes hide inside rocks or under stones. You too would rather not be blasted by sunlight while freezing. It is an unfair combination. Sunburn with hypothermia potential. A little gift from polar environments. Congratulations. The sun is trying to cook you while the air tries to preserve you. And then you think about human history. Again, because your mind cannot help itself. It wants to locate itself in time to put a date stamp on experience. Humans did not live in Antarctica historically. There were no indigenous Antarctic societies building long traditions on this continent. The place is too hostile, too isolated, too resource-sparse for pre-modern settlement. Antarctica entered human maps late, as a hypothesis first. Terra Australis Incognita, the unknown southern land, imagined to balance the continents in the north. People drew it before they saw it, which is very human, designing reality by symmetry. Then, exploration came. Brutal and often tragic. Ships pushing into ice, men hauling sledges, wintering over in darkness, learning the hard way that the continent does not bargain. The dry valleys were not the main stage for those early expeditions, but they are part of the same lesson. Antarctica does not reward effort with comfort. It rewards it with data, sometimes, and with a kind of stripped clarity. Modern research stations are the compromise. Humans building pockets of warmth and power in a place that would otherwise remove both quickly. Those stations depend on supply chains, weather forecasts, and careful management of waste, because the environment will not recycle it for you. And even then, humans are temporary. Bases can be dismantled. camps can be moved, the ice and wind remain. So you return again to that comforting indifference. You let the valley be what it is. Not a challenge, not a backdrop, just a functioning system. And you notice that the longer you imagine standing here, the more your mind slows to match it. Your thoughts become less like a scrolling feed and more like sediment settling out of water. You begin to accept that nothing needs to happen quickly. That is when you finally see the valleys the way they want to be seen. Not as an extreme place, as a baseline, a reminder of what Earth looks like without the distractions of abundant life. Rock, air, ice, salt, and then, inevitably, you notice the one thing that does not fit the baseline. You, your warmth, your moisture, your constant exhalation of water vapor and heat. Even if you are careful, you are a little cloud generator in a desert of cold air. You are a moving patch of chemistry and biology, leaking. That is why you would not survive here without technology. Not because the place is actively hostile, because you are not built for it. You are a tropical mammal with delusions of universality, and those delusions are easy to maintain in a world full of buildings, heaters, grocery stores, and pavement that looks permanent. The dry valleys strip that away. They show you the raw terms. Heat is precious. Water is precious. Shelter is precious. Distance is dangerous. Everything you do must be planned. Everything you touch must be protected. Everything you assume about convenience becomes laughable. So you stop assuming. And when you stop assuming, you can start appreciating the slow drama that is actually here. You watch wind move a veil of dust across the ground. It is subtle, like smoke hugging the surface. You watch it collect behind a rock, a small drift of fine particles building in a miniature lee. You watch the drift shift again when wind direction changes, a small dune perhaps, trying to form. In the dry valleys, you do not get classic sweeping sand seas, not usually, but you can get small aeolian features, ripples and drifts where there is enough loose sediment. Even here, the wind tries to build as well as destroy. It is just working with limited inventory. You think of dunes as desert icons, but dunes are really just the wind doing accounting, picking up grains, dropping them, building forms where flow slows. The exact shape depends on wind consistency, sand supply, moisture. In Antarctica, moisture is scarce, which should help dunes move, but sand supply and local conditions control everything. So, you get small gestures instead of grand dunes. And then you see a line of darker material on a slope, like a stain. Maybe it is just a different rock layer. Maybe it is a path where fine sediment has moved. Maybe it is a salt line, marking where moisture once wicked up and evaporated. You realize the valley is full of these quiet markings. It is like a notebook where the ink is mineral. If you had all the time in the world, you could map them. Trace how wind exposure changes soil texture. Trace how meltwater channels shift. Trace how glacier margins advance and retreat in tiny increments. Trace how lakes respond to temperature changes. Scientists do that in slow, careful ways. They install instruments. They drill through lake ice. They measure chemistry. They track stream flow during the short melt season. They photograph the same spots year after year, watching change happen in almost invisible steps. It is not glamorous work. It is patient work. the kind of work the valley respects. And if you listen to that, you might start respecting patience too, not as a moral virtue, as an accurate response to reality, because reality is not built around your schedule. Now, because your mind has been wandering through other landscapes tonight, it is tempting to compare, to rank harshness, to decide what is worse: cold dryness, hot dryness, coastal instability, mountain hazards. But the comparison is a trap. The planet is not trying to create a leaderboard. It is creating variety, different combinations of the same forces. In a hot desert, you lose water through sweat and evaporation. In a cold desert, you lose water through breath and dry wind. In both, dehydration is the quiet thief. In mountains, thin air and sudden weather shifts challenge you. In Antarctica, the thin air is less of the issue than the cold's constant drain. In both, the environment reduces your margin for error. Along coasts, the hazard is motion, waves, storms, erosion, sea level. In the dry valleys, the hazard is stillness, a lack of quick rescue, a lack of warmth, a lack of water. Motion can be dramatic. Stillness can be lethal. Different styles of indifference. So you let the ranking go, and you let the scene hold steady. The valley floor under a pale sky. Mountains in the distance. A glacier tongue like a frozen spill. A lake lid reflecting light like old glass. And wind, always wind. The wind becomes your metronome now. It sets the pace for thought. It reminds you that the atmosphere is not just above you. It is a moving mass, shaping everything it touches. You can almost feel the katabatic flow in a larger sense, not as a gust on your jacket, but as a system, cold air forming over the high ice sheet, densifying, then draining downward through topography. It is gravity again. Always gravity. And gravity does not just move air and water and rock. It moves ice too, in its slow, ductile way. It pulls glaciers downhill. It pulls slopes apart. It pulls talus cones outward. It pulls you into fatigue if you try to fight it for long. So you stop fighting. You match it. And in matching it, you begin to think about the one kind of time humans can almost relate to: slow daily routines. A base camp routine, a sampling routine, a careful walk routine where each step is deliberate. That is how humans adapt to these places, by creating rhythm. You can imagine a researcher here, walking to the same stream gauge each day during melt season, measuring flow that might only be a few liters per second. You can imagine them drilling into lake ice, lowering sensors, collecting water samples, analyzing salinity profiles. You can imagine the effort to keep everything sterile, because contamination matters in such a sparse ecosystem. You can imagine the boredom too. The long stretches of the same view, the same wind, the same cold, broken by small moments of discovery. A new microbial mat, a strange salt deposit, a stream running earlier than expected. The valleys teach you that small signals matter. And then, inevitably, you think about how Earth's climate changes could affect this place. Warmer temperatures could increase meltwater flow, alter lake levels, change microbial habitats, destabilize permafrost. Even small changes matter because the system is so tight, so close to thresholds. But you do not turn that into a panic story tonight. You keep it simple. The valleys are sensitive. They respond to shifts. They are not locked in amber. Nothing is. That is the deeper comfort, oddly. Even the harshest landscapes are not permanent prisons. They evolve. They transition. They have histories and futures. And you, being human, will only ever catch a glimpse of one frame. Now you step closer to the glacier again, just in your mind, and you watch the surface, texture, small ridges, wind-carved snow if any exists, dusty patches, faint blue and denser ice. You imagine the ice crystals inside slowly deforming under stress. Ice is solid, but it flows like a very slow fluid. That is why glaciers can move without melting. They creep internally. Crystals rearrange. Pressure causes deformation. It is slow enough that you can deny it, but persistent enough that the glacier travels anyway. You could put stakes in the ice and measure movement over a season. People do. The numbers are small, but the consequence is large over time. And as the glacier moves, it transports not just rock on its surface, but sometimes dust and debris within it, frozen into layers. Those layers can be like annual pages, recording past deposition, past storms, past volcanic ashfall. Ice as an archive again. It is a recurring theme tonight. Landscapes as memory. Mountains remember collision. Coasts remember sea level. Rivers remember floods. Deserts remember cold persistence. And humans remember very little by comparison. A few thousand years of written record, a few tens of thousands of years of oral tradition at most, a blink against the valley's quiet endurance. That should make you feel small, but it can also make you feel free. Your mistakes are not permanent in the way they feel at midnight. The planet has handled worse. The planet has reset itself repeatedly. It will reset again, with or without your consent. So, you let that thought settle like the finest dust, and you keep walking. You notice a patch of ground where stones are arranged in a ring, a sorted circle perhaps, where frost processes have pushed larger stones outward and finer material inward. Sorted circles can form in periglacial environments, shaped by repeated freeze and thaw and the movement of water within the soil. In places with more moisture, you can get ice lenses forming, lifting soil and stones. In the dry valleys, moisture is limited, but the processes still happen, enough to leave patterns. The ground becomes a slow, self-organizing system. It is geometry built by temperature gradients. And once you have seen it, you cannot unsee it. You start spotting patterns everywhere. Faint stripes on slopes, polygons on flats, stone rings, sorted patches. The valley floor becomes a quilt. Not a warm quilt, obviously. A quilt made of rock and time. Now you step toward a slope where the rock face is fractured into plates. You see flakes that have peeled away. You see fresh surfaces lighter in color than the weathered exterior. You think about the mechanisms again. Freeze-thaw, salt crystal growth, thermal stress. In reality, they overlap. A rock might crack a little from thermal contraction. Then water enters, freezes, widens the crack. Then salts crystallize in the pore spaces and push further. The rock does not care which mechanism gets credit. It just responds. Erosion is a team sport, and once fragments fall, gravity takes over. They tumble down, bounce, settle. Over time, the talus slope builds. The angle of repose holds the pile at a stable steepness until more rock arrives and causes small slides. A talus slope looks static, but if you could watch it in time-lapse over centuries, it would shimmer with tiny movements. This is what the dry valleys offer you, a chance to imagine time-lapse without the distraction of too much life. And that brings you back to the idea of deep time again, but softer now, less intimidating, more like a slow lullaby the planet hums constantly. Wind, sand, stone, ice. You could stay here forever, mentally, because the place never demands a climax. It never asks for a dramatic reveal. It just keeps repeating its processes, refining them, polishing them, filing the world down. But your mind, even sleepy, likes to wander to edges, and the edge that keeps calling now is the boundary between ice and land, the way the dry valleys sit beside the larger Antarctic ice system. So you let your imagination drift outward from the valleys toward that vast white interior. You do not walk all the way into it. You simply acknowledge it. The ice sheet, thick enough to bury mountain ranges, flowing outward in slow streams of ice, called ice streams, feeding glaciers that reach the sea. At the coast, those glaciers can form ice shelves, floating platforms attached to land ice. Ice shelves are like doorstops. They buttress glaciers behind them, slowing flow into the ocean. When shelves thin or break, the glaciers can accelerate. Again, not a story you need to finish tonight. Just a reminder that even the biggest ice on Earth is not static. It flows, it calves, it fractures. It responds to temperature and ocean conditions. So when you stand in the dry valleys, you are standing near a giant moving mass, even if your local ground is bare. The continent is still in motion. And that is the final trick of Antarctica. It looks like the definition of frozen permanence, but it is actually dynamic, just at a pace and scale that humbles you. Now you come back to the valley one more time, and you focus on something small and human. A piece of equipment left out would frost over, then dry out, then crack under ultraviolet and cold stress. Metal would contract. Plastic would become brittle. Anything with moisture would freeze hard. Batteries would lose capacity. Lubricants would thicken. Even simple mechanical systems become unreliable when cold steals flexibility. You realize how much of your modern world depends on materials behaving within a narrow temperature range. How many adhesives fail in cold? How many screens lag? How many seals shrink? How many fuels gel? The dry valleys are not just hostile to biology. They are hostile to convenience. So when humans operate here, they bring redundancy. They bring repair kits. They bring patience. They bring procedures. They make checklists because memory becomes unreliable when cold and fatigue mix. This is why polar work looks boring from the outside. It is a lot of careful repetition, and boring is not an insult. Boring is how you stay alive. Congratulations, the most exciting survival skill is consistency. Now you let that settle, and you keep the scene calm. Wind continues. Light remains bright and cold. The valley holds its shapes. And because the outline of your night still has more map to cover, you let your mind hover between places again, ready to pivot, but not rushing, not leaving the dry valleys entirely, just letting them become a reference point, a baseline of emptiness. From here, every other harsh landscape becomes easier to understand because you have felt what it means for the planet to remove softness. So you begin to wonder, quietly, what other places on Earth feel like the planet forgot to finish them? Places where the rules are simple and the costs are high. And you let that question